Hello, I'm Jennifer McClendon, Education Manager for Sportsfield Management Association. Welcome to SFMA's post-conference virtual education webinar series. Today's speakers are Dr. Dan Sandor and Dr. Jada Powlen. Dan Sandor is a collegiate assistant professor of turfgrass at Virginia Tech. He holds a 100% teaching appointment as he leads all undergraduate coursework, chairs undergraduate research, advises and mentors students, and serves as the faculty advisor for the Virginia Tech Turfgrass Club. Dr. Sandor directs multiple recruiting initiatives of prospective Virginia Tech turf students and has built and developed strong connections with high school agriculture and green industry programs across the Commonwealth. He has also engaged in multiple turfgrass research, extension, and outreach education efforts at Virginia Tech, as he serves as the education chair of the Virginia Sportsfield Management Association. Dr. Sandor earned his PhD from the University of Arkansas's Turfgrass Science program in 2018, and he served as a postdoctoral associate with the University of Minnesota Turfgrass Science program prior to joining Virginia Tech in the fall of 2019. Jada Powlen is a lead research scholar in the Department of Horticulture and Landscape Architecture at Purdue University. Her research focus is in turfgrass science and ecology. Her expertise is integrated systems for sustainable turf management with a focus on promoting superior grass species cultivars, reduced cultural inputs, nutrition and supplemental irrigation, and reducing pesticide needs. Dr. Sandor and Dr. Powlen will be presenting dollars and cents, practical math to maximize savings. Speakers?
Thank you, Jennifer, for that introduction. And thank you all for being here today. So I'm going to turn things over to Jada. So
thank you again for all being here. So today in this seminar, we're first going to look at how to calculate different product requirements and evaluate different application costs, looking at multiple different products within a specific category. Also looking at seasonal management practices and can influence application costs and how that impacts your budget. And then also understanding at the end how to use spreadsheets to help maximize and calculate different products, because you may get a catalog of different products that may have tens to hundreds of different products, and how do you compare those application costs without actually having to manually write those out over and over and again. So you can use spreadsheets to help speed up that time and effectively compare not only different products but from year to year, keeping those and help you understand the differences between those products. So why understanding calculations for fertilizer and pesticides are important? First off, it ensures your proper application. So you need to make sure you're actually applying what you want, when you want, and how much you want over a specific area and field that you have. The next is environmental safety. Especially when we come to these products, maybe not for a seed, but for fertilizer, pesticides, making sure you're not over applying these products, especially with some of these pesticides having a negative public perception, and making sure that you are staying safe as well when you're handling and applying these products, not also, for yourself, but also that it's safe for the turf as well. And then finally, for budgeting purposes, these chemicals and products cost a lot of money, and again, depending on what product you choose. And so if you over apply, that could really add up as far as your application costs over time. So first thing you need to know is what area that you're applying for. So depending on what you're using or what field you have, what facility that you may be in, not everything is exactly maybe a square. So this is an example of showing that a sports complex that has both football and softball and baseball, but also has any sort of outside, just general use turf areas that would be considered an irregular shape. And so although some things can be easily calculated using, just the area of a rectangle, an oval, circle, sometimes you need to use other tools to help you. And things that we're going to look at would be, square feet or 1,000 square feet or acres. And that's really important when it comes to specific labels as far as pesticides or any sort of fertilizer calculations, knowing what the label recommendation is, 1,000 square feet or acres. So one way in the kind of the traditional way of estimating these areas is just grabbing that tape measure, grabbing the wheel measure, and then marking off and measuring out the areas, and then doing the math itself. You can also use some sort of offset. So whether it's offset method or the modified offset methods for irregular shapes. So for instance, you may have a pond in the center of your facility, and you need to be able to use that modified offset method to be able to measure out what that pond estimate would be. And the Golf Course magazine has this article that can help you calculate your specific area if you're wanting to use this traditional method. There's also other methods, especially with Google Earth, other online satellite tools that are free, can help you measure out irregular shapes. So this is actually at Purdue University, our baseball field, and then to the left is the racetrack. They run their Grand Prix every spring on that track, and so you can see that shape is very irregular, and so you can actually use whether it's this Acme planimeter to help dot out the area, and it will at the bottom calculate whether it's in acres or square feet, what that specific area is. So you can use this Acme planimeter, or you could also use Google Earth. You can do the same thing. And when you're doing this, again, the more points that you put, like for this softball field, the more points you put around the edges helps get you a more accurate square footage when calculating this online. Now, I will say if you have any sort of trees blocking the area or the field, that's when you probably need to get the tape measure out because those trees aren't going to block any sort of dot that you can put. Now, you could estimate it because you know your field, but to be more precise, you may have to use the traditional method for that.
And I'll just jump in real quick, Jada, and say it's also going to be largely dependent on the current imagery from the satellites. Like I know at Virginia Tech here, our football field is actually right behind where this box is, and it's in the image, I think it's not even grasped in part of the areas, and so that's one of the downsides to using the technology is you want to make sure the satellite imagery that it's using is the most up to date, especially if you've made any adjustments in your dimensions or any renovations or things.
Good point. Thank you, Dan. So again, I mentioned it earlier, but knowing before you make any applications, know if your application rate is in acres or 1,000 square feet. Very important for that. So whether it be fertilizer, top dressing sand, any plant growth regulators, wetting agents, they're often expressed as that acre or 1,000 square feet. If we have any other internationals and friends on this webinar, then it may be in hectares, but for the most part for the United States, it's either going to be acres or 1,000 square feet. And if you see something with the Roman numeral letter M, that is an abbreviation that some people will use just as a shortcut for 1,000 square feet. So just be aware of that. And so again, if you're just doing this basic calculation, so 1 acre is 43,560 square feet. So for example, if you had a 20,000 square foot area, would be equivalent to 0.46 acres. Same thing for that next one's 0.79 acres. You would multiply that by 43,560 to get 34,412 square feet. So again, it's important to know these areas and units to calculate before you get started. And the reason why is this is kind of a warning image looking at, this is a student trial that we did at Purdue University a few years ago, looking at different PGR chemistries and different rates. And so we actually, since most PGRs are actually ounces per acre, we wanted to say if you accidentally misread the label and thought it was ounces per 1,000 square feet, what would that look like? And so this image is actually showing PGR application, and it was actually like 2 hours after we made the application, that creeping bent grass turned brown, stopped growing. It took a full year for those 4 replications of the same treatment to come back. So again, it's really important to know what your unit is, and when you're making these calculations, is really important to know what the label is saying. All right, so I'm gonna let Dan take over this from here and
Yeah,
keep going.
so yeah, thanks, Jada. And Jada will be back, and so jump in here too. as well, but to kind of switch it up, uh, hopefully this is not the first turf math presentation you've ever heard, but lucky for you if it is, you get stuck with us. But there's a lot of different ways to do math. If we all grew up in different schools, different states, probably maybe even different countries, as Jada alluded to earlier. We're not throughout the lecture today or the webinar today. We're not saying that our way is the best way to do it. There's a lot of different ways where we can all arrive at the same answer. So please pick a way that works best for you. We are going to highlight 3 different ways to begin with today. And the one that Jada and I really like is the stoichiometry method or the relational method. But there's a couple other ways that people have utilized or even taught math in years past. One is the proportional method, which is using cross multiplication. There's one that I don't know if this is the actual term for it or not, but I just kind of threw it up there as categorical, which is describing products in terms of the want over have equals how much you may need, or want over have equals need method. This is one that I know is taught throughout Virginia high schools here, throughout the Commonwealth, and it kind of incorporates the proportional method or the cross multiplication methods in like kind of the second part of those. But the relational stoichiometry is one that Jada and I really like for a number of reasons, but it really helps kind of tell the story and helps you kind of lay everything out on the table in terms of what you're starting with, what you and where you're trying to get to, and all the things that are involved along the way. So we're going to do a problem real quick together and show you the different ways that you can do these 3 different methods based off this one similar problem. So you've got a football field, 57,600 square feet. You want to fertilize at a standard rate of half a pound of N per 1,000 square feet using 4600 using urea fertilizer. And so let's do some proportional math or some cross multiplication where you would set this up as half pound per 1,000 of N per 1,000 square feet. Well, how many pounds of N do I need for my football field, right? If I am fertilizing at the rate of at this rate, how many pounds of N do I need for my football field of 57,600 square feet? So you do the cross multiplication and it equals out to about 28.8 pounds of N required for that field. But then how much of that is how much fertilizer do I need out of my 4600 fertilizer? Well, in 1 pound of fertilizer, there's 0.46 pounds of N. So if I need 28.8 pounds of N, how many pounds of fertilizer do I need? Set up the cross multiplication, and you would need 62 pounds. A little over 62 pounds, or about 63 pounds of this 4600 fertilizer. So I think many of you have hopefully seen the cross multiplication method. And again, there's multiple steps to this, right? And you may have been able to figure this out a different way along the way. Again, this is just one of many ways to do this. The want over have equals need method is again the want method I see a lot in different high schools. Incorporates a lot of the same principles of cross multiplication. What these equal out to, or where these labels or categories come from is, you want to be applying a half a pound of N, which is your want. You have is this is the amount of N, or let's say, if this is a pesticide problem, the pesticide rate, the amount of active ingredient in the pesticide is what you have, or in this case, a fertilizer, the amount of N or nutrient that you have in that bag of fertilizer, and then what you need or what is required, how much fertilizer you need. And this is all based upon your area unit. So whether this 1,000 square feet or whether this is your acreage. So 1 over have equals need in this instance. And so this still, ends up being similar to cross multiplication, where you take 1.9 pounds of fertilizer over your football field, divide it by your 1,000 square feet, and because this is your want over have equals need here is 1.09 pounds. That's where that came from. And then you still got that over your 1,000 square feet. You got to get over your football field. and it still comes out to similar to what we had before, a little over 62 pounds, or, we want to round up to 63 pounds of 4600 fertilizer. But let's show you guys some stoichiometry. A lot of people aren't familiar with this, or maybe they're hesitant to try it. Stoichiometry is kind of hard to say, or kind of hard to visualize. We don't really talk about it a lot outside of like chemistry classes in terms of the turf world, but we really like this method. I know a lot of Purdue grads use this from Dr. Aaron Patton's, decades of teaching and extension work. But in terms of figuring out to make sure you have everything you need, we like to use units because they relate to one another. There's a lot of things that convert in terms of conversion factors, maybe going from ounces to pounds, or from, ounces to gallons, like fluid ounces to gallons, or those types of things really help and those things. And so this is how you set this up in terms of stoichiometry. I always like to start with my rate. So in this instance, again, same problem we've been working with the last two slides, half pound of N per 1,000 square feet. We've started with our rate here. And so what we have on the top, we've got to get rid of if it's not our final answer. We know our final answer needs to be pounds of fertilizer, right? So pounds of fertilizer. Well, this is on the top. This is in our numerator. So pounds of fertilizer, or 1 pound of 4600 fertilizer. We also know we need to get rid of this pounds of N on the top here. So we need to cancel this out. So pounds of N on the top, pounds of N on the bottom, they cancel out. We also are just looking for how much do we need for our football field, right? I didn't write it here on the screen, but football field was essentially be on the denominator here where the red dot is. But we need to get rid of this 1,000 square feet here. So the way we get rid of it, this unit down here, is we know the size of our football field is 57,600 square feet. So this is, you're thinking on Dr. Powlen, Dr. Sandor, okay, like how do I know when I'm at the end, or what do I do when I get to the end? It's just like reading a book, right? Or reading a piece of paper, there's one line after the next, except for in this case, you only have 2 lines. So it's really simple. So read the top row, and instead of reading it, what you're going to do is multiply across the top, and then divide across the bottom. And then I like to press equals only at the end. So I know some of my students from time to time, they've, done all the multiplication across the top, they press equals and then they start dividing. I recommend, both Jada and I recommend not pressing equals until the very end. So the way we would compute this in terms of stoichiometry is you take a half a pound, or basically you would be just writing in the numbers in your calculator. So 0.5 times 1 times 57,600 divided by, because we've gotten to the end here, so divided by 1,000 divided by 0.46 should give you 62.6 pounds of fertilizer required. And I know these were a little bit off in terms of the 10th of a decimal point. At the end of the day, you're going to be rounding up in most cases for whether it's pesticides, whether it's PGRs, wetting agents, top dressing sand, fertilizer. You're going to round up, for obviously you may be treating more acreage than just one field at a time anyways. But you can all see these were, right above 62 pounds of 4600 fertilizer. So
That's
go
because
ahead.
yeah, because you're carrying through the calculator on stoichiometry, whereas your other methods, you're getting one answer, you may be writing it down, doing it in the next step. So that is one way. It might be a little bit different as far as to the decimal point between one person versus another, different methods.
Yeah. And just be aware that at the end of the day, if you're not too sure, do the problem again. Check yourself, check your math, and make sure the units cancel out. One thing that I want to see if I can draw on here. One thing that Jada and I like to do, we encourage the students to do, is just make sure things cancel out. So you've got square feet cancel out, because that's good, because we're not looking for an answer in square feet. Remember, we're mainly just looking for how much fertilizer, how much of, see if I can say, how much of this fertilizer do we need? So our answer, our numerator answer should be that. So we don't need pounds of N, so those cancel out. And so at the end of the day, if this was more work, if this was something more with like top dressing and converting from like, cubic feet to tons or something like that, there may be a lot more, columns in here. But this one's pretty basic, pretty straightforward. We know, okay, well, pounds of fertilizer, this is what we're looking for here. And so we're good to go. We're ready to solve the problem. And we have this on the top as standing alone. Again, football field, we could have written that on the bottom here. It's pretty intuitive though. So, all right, so kind of a quick breakdown, a quick review of what we just covered before we get into some more of the actually, what you came here for, the dollars and cents, is to list what you know, start with the rate. Another way to do the stoichiometry is to maybe work backwards. Okay, your answer needed to be in pounds of fertilizer, so that's going to be on the numerator. So then you could put, 1 pound of fertilizer on the top, 0.64 pounds of N on the bottom, and work your way from there. Either way you decide to work it. I was taught, I think Dr. Patton teaches the same way, always to start with your rate. Whether it's a pesticide, whether it's a fertilizer. And then just like we just did, arrange your work where the units associated with the final answer are on top or the numerator. Cancel out, all the other things that you don't need, make sure they cancel out. And some of the things you may not have right at your disposal. You may not have that in the problem like we did with the football field example. Maybe you have, a recommended fertilizer rate in 1,000 square feet. You know how many acres you need to fertilize. Maybe, obviously football field is about 1.3 acres or so, but let's say you're doing multiple fields. You may have to fill in the blanks along the way with some common conversion factors, like, a gallon is 128 fluid ounces, 43,560 1 acre, 454 grams in a pound, so forth. So, that's where some people I see get stuck. Some of my students get stuck is, well, where do I do next? How do I go from one to the other? A lot of it's just reaching back into your, knowledge and your education you've learned along the way and just plugging in some of those common conversion factors. And then at the end of the day, once you're ready to do the math, just remember, multiply across the top row, divide across the bottom row. You should get your final answer. And so we kind of covered this a little bit already. We're going to kind of skip through it a little bit, but in case you didn't read the summary of the talk today, we're not so much going to talk a lot about making applications or, how much product do I need for different scenarios like top dressing, aeration, fertilizers, fungicides, whatever, chemical products. There's already a great presentation online, and the slides are online somehow. I don't know how or where, but I just typed in, I knew Dr. Bigelow and Dr. Stewart had given this presentation a couple years ago. I've linked it there in the PDF file. They do a really good job of kind of going through all of those things. And that presentation, if you are a SFMA member and attended the 2023 conference, you should still have access to that recording. You can go back and listen to Dr. Bigelow and Dr. Stewart talk all about, turfgrass math in terms of as it relates to applications and things like that. There's a lot of other resources as well, in addition to their presentation. There's some textbooks that we're going to link at the end of the presentation. A lot of your university experts, your turfgrass extension specialists should be able to help you out either in your state or in a neighboring state. There's also a lot of good extension publications out there that kind of give some overview of turf mathematics. There's a lot of trade, popular press or popular and trade publications, industry publications out there as well. One that we just highlighted from the GCM, Golf Course Management Magazine. The Turfgrass information file is now open access, and you can type and use that database there. YouTube, there's a lot of YouTube videos now from turf managers, turfgrass researchers and scientists and educators out there. And then, as we mentioned before, SFMA has a number of conference sessions on math, and there's lots of seminars and webinars that have already been recorded and produced on their YouTube channel, on their member hubs and different resources there. So today's class, though, we are going to, again, give you what you came here for and really talk more about the economics and thinking about things in terms of their cost and helping you with your budget. And the reason for this is because in Dr. Stewart and Dr. Bigelow's presentation, they actually ran out of time. They didn't have time to get to that. I think they may be some slides in it, but I was talking to Jada about it. It was like, one of the areas that I think, we can really contribute to is providing more of the economics and the dollar component, because we realize, okay, once you guys figure out how much you need of a certain product, a pesticide, a fungicide, whatever it is, fertilizer, you then have to weigh your options, as Jada said. You may have a lot of different things at your disposal. Which one, or in the catalog or whatever from your vendor, which one best suits your budget? So let's think about this in terms of seed. And fair warning, I realized when we were about to sign on here, I forgot to include a bunch of animations in here, so everything didn't pop up at once. So some of these may be out of order. So I may quickly move through these to get them all on the page at the same time, but I apologize for the what appears to be some disorganized animations here. But if you guys have ever, seeded or turf area, fields, whatever, renovations, establishment projects, you may have probably seen this recommendation from your university experts or industry recommendations on establishing turf according to pure live seed. Because remember, not everything in the bag is grass seed, and not all the grass seed is going to germinate. And so here we go. So you want to, again, multiply the percent purity by the germination for each variety or cultivar listed on the label. You can use some shortcuts, if multiple species or varieties have equal germination, then you can add up the purity and then multiply by the germination. Again, we're not going to go through all the math involved with this, because this is all stuff from Dr. Bigelow and Stewart before. But just to give you an example, these two bags are labeled the same, right? Hound Dog brand, tall fescue blend. They each have tall fescue. It's just a blend, and both of these, no bluegrass, no ryegrass. But you can see a great difference in, and they're both 50 pounds. You can see here, but yet there's a big difference in terms of the actual pure live seed in these products, right? 84, almost 85%, as opposed to just a little over, 42% PLS, and that largely has to do with this coating here in this product. So it's just something to keep in mind. So when you're looking at these seed products that you're trying to choose from, so calculating cost per pound of pure live seed. So maybe you've identified that you want to use a couple of different products. You have a couple of different options. Maybe you're overseeding for ryegrass, and you've got a couple of different seed options and different things. So doing this math, like, in terms of calculating the cost per pound of pure live seed, is going to help you identify the best value. And so the formula, in terms of stoichiometry, is you have your cost per pound of seed, and then you've got your data here from what you've done the math in terms of how much pure live seed, how many pounds of pure live seed are in 1 pound of seed. And so let's say this product here, Ewing Park's grass seed mixture, what's the cost per pound of PLS or pure live seed if the product costs $74.99? And so you can just easily put in this data that you have from the seed tag and from the price point. And so on the seed tag, we can get the pound of seed, and we can also calculate the pounds PLS. We didn't do that for you here. We just kind of did it before we put these numbers together. But if you add all this stuff up and develop and determine the PLS, it's 0.8782 or 87.82 percent pure live seed in this 50-pound bag. Then you got your price point from your distributor, from your vendor, catalog, wherever you get that from. We see this product is $1.71 per pound of pure live seed. So you could easily, again, to do the stoichiometry, $74.99 times 1 divided by 50 divided by 0.8782 equals $1.71. So. All right, so let's compare two products. And again, we've got two different seed products here. We've got Seed Blend 1 and Seed Blend 2. Let's do Seed Blend 1 first. So Seed Blend 1 is $4.65 per pound. And sometimes, if it's not given to you in price per pound, you can just, as we did on the last slide, you can just go with the price and look at the bag of seed and how many pounds or how much that bag of seed weighs. But here the cost is already given to us in terms of cost per pound based upon this seed tag. And then we see our pure live seed here based upon our purity and our germination percentage. And so this seed blend 1 is $6.12 per pound. Whereas seed blend 2, we figured out our pure live seed, which is 38% PLS. And so again, if this one costs $4.65, and the really cool thing about this problem too is both of these cost the same, right? So what is the better value if they both cost the same? Well, this one is again $4.65 per pound of seed, but it has a much lower pure live seeding rate. Again, and it's not always due to the coating or to something else, but there may be a mulch material, there may be some other things in the bag. Hopefully not anything like weed seed or crop seed, or a lot of other inert materials. There may be really low germination affecting that, but sometimes what you see in a lot of these mixes is just the coating that makes up a lot of the difference. So you see that coating really affects our pure live seeding rate, or our pure live, not rate, pure live seed amount in this product. And so we see, even though these products, maybe on the shelf, they look the same in terms of, the same price point, or they look the same price or the cost, you're actually getting a better value with seed blend number 1, because you're only paying $6.12 per pound, whereas you're paying, nearly double with seed blend 2. So that's a quick and easy way to figure out better value or the dollars and cents, if you will, of seed calculations. All right, moving along, we're going to kind of hustle because I know Jada's got some really cool slides to show you here at the end using setting all these up with spreadsheets. So we're not going to spend too much time on this. You guys know this, right? NP and K, percent N, percent P2O5, and percent K2O on our bags of fertilizer. So let's move along. But you can go back and revisit this again on if you're viewing the recording afterwards. But hopefully how to determine the amount of the pounds of N, P2O5, and K in the bag. Oop, got ahead of myself here. All right. So what in this case, instead of cost per pound of pure live seed, we're figuring out the cost per pound of nutrient. The cost per pound of nutrient. So that is the nutrient you are, wanting to apply. In most cases, it's probably nitrogen. You can identify, the best or the better value. So again, you have your cost per pound of product, in this case, fertilizer. And then you've got 1 pound of fertilizer. How many pounds of that nutrient, whether it's N, P2O5, or K, do you have? And so let's look at this problem here. What is the cost per pound of nitrogen in this 24-8-12 fertilizer? And I put a weight on there and just put an arbitrary price point on there as well. So $27.99 for a 50-pound bag of this fertilizer, this 24-8-12 fertilizer. Well, if you remember from the previous slide, 1 pound of fertilizer, of this fertilizer, there would be 0.24 pounds of N. So you do the math, $27.99 times 1 divided by 50 divided by 0.24, that should be $2.34 per pound of N. Let's do another example. Now we're going to compare some products, some really creative fertilizers here. We've got Powlen Power and Sandor Special. So cost per pound of nitrogen. Let's compare 2 products. So Powlen Power has 2400, and Sandor Special is 2100. Jada's fertilizer is a little bit more expensive than mine, and hers is at $27, but it has 24% nitrogen in it. Mine is $23, but it only has 21% nitrogen in it. So you do the math as we just saw before, price per pound of seed, or price, and then know how many pounds are in that product, and then your nutrient analysis in terms of pounds of nutrient per pound of fertilizer. Do the math, and you can actually see that mine ended up being just a little bit cheap. Again, this example, maybe it's a little bit extreme in the sense of, okay, this is only a 5 cents difference. But in the real world that you guys are dealing with, you may see a much greater margin between different products. Here, and even with a 3% difference in the amount of nutrient as well, can go a long way. Let's do a different example though. Let's look at two products if we're applying them at the rate of a half a pound of N per 1,000 square feet. And so we've got two of our mentors here, Dr. Bigelow, Dr. Goatley. You guys all have heard of these two professors, but Bigelow Best and Goatley Goodness. So it's hard to put this all on the screen at the same time for you again. And let's just look at this top one there if you're following along. So Bigelow Best at the rate of half a pound of N per 1,000 square feet. If I'm applying this at this rate, what is my cost per acre? Cost per acre. So you've identified, maybe you've identified your cost per pound of nutrient, but what is my cost per acre? What is my per acre cost for each of these two products, between each of these two products? And so let's do our rate. If I'm applying if I want to apply nitrogen, if my nitrogen program is scheduled to be at a half pound of N per 1,000 square feet, my per acre cost is going to be $43 per acre with Bigelow Best, or $48 per acre with Goatley Goodness. And again, this number, do the stoichiometry. Here's your rate. Here you flip this upside down, to cancel out your pounds of N. Then you've also got to, think about, your per acre cost, right? So you're applying this to 1 acre. So you need this many pounds of fertilizer per acre. So this is how much you're applying. This is your total cost per pound of fertilizer. This is how you get the dollar per acre amount. Similar math, similar strategy here with the cost per acre for fertilizer. All right, moving along. I know we're going fast. We're actually almost running out of time. I just realized. So we put a lot of math in here for you guys, but we're going to speed it up a little bit. So irrigation calculations. This is something that is actually becoming a little bit more of a concern for folks in our industry, even in sports fields, because water conservation efforts, again, all well and good attention, but if we had to budget or estimate the cost of water per season, we had 16.7 acres of Kentucky bluegrass fields. We know we're going to irrigate with 1 inch of water per week. Another conversion factor for you is there's 27,154 gallons of water to apply 1 acre inch of water. This acre inch represents 1 inch of water across an entire acre. So you have that 43,560 square feet. You've applied 1 inch of water basically sitting right on top of that. And so you can figure out how many gallons of water you would need for that 16.7 acres to apply that during the drought season. And so you've taken your 453,472 gallons of water, which to apply 1 inch, and you're going to apply and this is just 1 inch, you're going to apply 14 inches of irrigation over a 14-week period, right? About 1 inch per week. Let's say, in the summertime, you roughly, there's about 14 weeks of drought stress, maybe not all at one time, but sprinkled throughout the summer. And so you're going to budget for that. And so these units of inches cancel out. So how many gallons of water you'll be applying. So that's over 6 million gallons of water across your acreage. You're typically, not all the time, but typically you can contact your utility or your provider, and most of the time they'll provide you a cost of water in terms of cubic foot. An easy conversion factor is, and 1 cubic foot of water equals 7.48 gallons, right under 7.5 gallons. So again, gallons cancel out, 7.48 on the bottom, over our 6.3 million gallons here on the top, 6 million, 6.3 million. I trying to think of how to set this numbers up. 6,348,608 gallons. Basically multiplied by 1 divided by 7.48 gives us our cubic feet. You can multiply that by your price point from your utility provider and figure out, it's going to cost almost $60,000 or over $59,000 to irrigate over this 14-week period. So then you can make your adjustments from there. All right. Moving on to the pesticide, you guys are probably dealing with this quite a bit as well. One of the big important things to consider when selecting with different products, again, we're not going to talk about making the applications, but there are different options for you out there in the pesticide world in terms of the formulations, right? Ounces or ounce. And sometimes pesticides are recommended to be applied, based upon the active ingredient per area, pounds of active ingredient or fluid ounces of active ingredient per 1,000 square feet or per acre. Understanding the difference between the products you have, dry formulations such as these on the left-hand column are percent AI per pound. Liquid formulations are pounds of AI per gallon. So that's a very important thing to think about, not only when trying to figure out how much to apply or how much product you need, but also in terms of determining best value or cost per application or cost per pound of AI. You also don't want to forget your conversion factors up here. We just threw a little table up here for you, going from fluid ounces to pints to quarts to gallons. So this is a lot of math here, again, but to kind of speed things up a little bit, you can calculate the cost per pound of AI, the cost per pound of active ingredient. And this is very practical when you're trying to figure out, what is the best value for my budget based upon the different formulations of a AI that may be available in this instance, 4 different formulations. So in this example, consider a pesticides available and active ingredients available in multiple formulations, but it's at various prices. Which of the formulations below, the 4EC, the 50WP, the 6G, or the 16F, is the best value per pound of AI? So Jada and I have done the math for you here, and you can follow along here. But we see out of all these products here, we see the best value is the 16F formulation listed here on the last column, even though it, $48 per gallon was the second highest, kind of price point here. The actual value in terms of pounds per AI here was just at $3 per pounds of active ingredient. So in terms of cost per acre, again, similar to our math that we've done earlier today, looking at amount of pesticide per area and then the cost per unit, similar to what we just did with our fertilizer math. If I'm applying this pesticide at the rate of 16 fluid ounces per 1,000 square feet, and then you've got your cost incorporated in here, the fluid ounces cancel out, the square feet cancel out. You got your price point here, the units, the gallons cancel out as well. So all you're left with is the unit for dollars and then your acre unit here. So your cost per acre. Do the math across the top row, 16 times 50 times 1 times 30 times 43,560, and then divided by 1,000, divided by 1, divided by 128, divided by 1. It's $272.25 per acre. Comparing between two products, this is really important to consider as all of you are thinking about different pesticides and active ingredients that have gone off label or gone off patent. Lots of different trade names out there, but have similar active ingredients. As again, Jada and I is always going to tell you, make sure you follow the label. Don't be spraying nothing that's not labeled for your sports fields or athletic fields or the turf grass species you're dealing with. But that's always first and foremost. But in obviously in our world of turf grass management, there's a lot of different options out there for you. So let's compare two pesticides that have the same AI, fungicide A, fungicide B. Let's assume they both have azoxystrobin in them, but you see different amounts of azoxystrobin, right? You have 8.8% and you have 22.9% AI in these products. Let's look at their cost per acre based upon their labeled rate. And so, fungicide A, and these are actually, I'm not going to tell you the products, but these are actually pretty close to some currently labeled fungicides out there that both have azoxystrobin at these actual AI percentages. So in their recommended label rate, and again, a lot of labels provide you the rate in terms of fluid ounces of product, maybe not, fluid ounces of AI or pounds of AI, but amount of product you need. And so these are the labeled rates for these two products, these two unnamed products, but 2 fluid ounces product per 1,000 square feet and 0.77 fluid ounces of product per 1,000 square feet. You do the math, you got to cancel out fluid ounces, you got to cancel out your square feet, cancel out your gallons, so you're left with dollars per acre. You see this fungicide B here is actually a lot cheaper, significantly cheaper compared to fungicide A at $73 per acre. One of the things that Jada and I do want to also point out to you is thinking about these different options as well. This is where you get in trouble. Sometimes I meant to pull out this asterisk down here, or sorry, up here at the beginning. Even though you have fungicides with similar actives, the inert ingredients, are maybe highly different or variable one product from another. So that's why it's really important to make sure your product you're using is labeled for athletic field turf and also for the species that you're doing. All right, Jada, sorry, I haven't left you much time to go over the spreadsheets. So
Yeah, and one thing to follow up with what Dr. Sandor said is that between those products, again, some of those inert ingredients could contain some sort of like sticker or adjuvant or something else that could help you in those products. Maybe not quite that price difference, but again, any of these fertilizers versus pesticides, you have to assume that they both meet your needs, and it's not something else that is contributing to that cost. So it's just a general understanding the difference between the two. And so when we come up to this next section of looking at spreadsheets to calculate cost, really it's looking at these products from a dollar amount, cost per acre, 1,000 square feet. But you have to make sure that they are fitting your needs. So for example, when we do the fertilizer calculations, understanding that say a urea product or some of these soluble products, a urea or ammonium sulfate, are probably going to be a lot lower in price compared to our slow release polymer coated ureas. But you have to take that into consideration, one versus the other, and how they perform differently and when you would use one versus another in your agronomic program. So when we talk about using spreadsheets to calculate costs, depending on what computer you have, and if you have Google or Excel, they'll both do the same sort of thing in helping you calculate fertilizer, pesticide, seed needs, everything we talked about today. And so these can really help you compare, up to hundreds of products. And again, like I said before, helping you keep track of from year to year and maybe updating the price or updating maybe the percent nitrogen or whatever it may be. And then you can make those calculations pretty quickly. So again, when we talk about spreadsheets, when you get started, always make sure you check your spreadsheet answers with your hand calculated answers, because if you're off and you're kind of dragging the formula through the spreadsheet, you're going to mess up all your numbers if you don't make sure that how your formula is and is calculated by hand, like what we did for earlier with what Dr. Sandor had. And so these spreadsheets can really be customized to your specific programs and how you like to kind of see things on the sheet and how it is relevant to your specific program. So first, we're going to start with calculating fertilizer needs. Really quickly, just kind of the way you kind of set it up and can kind of give the fertilizer information here on the left side. And as you're kind of working from left to right, you would enter that information as far as the name, the percent nitrogen, what your desired rate is, the particular pounds in this the bag, and then you would also know your cost for an individual bag. And the things you would calculate in Excel would be things like pounds per acre, then cost per pound of nitrogen, and then give you an overall cost per acre. And then you could be able to calculate either cost per pound of N or cost per acre to compare these different products. So then if we look at the information you need to enter, like I said, your percent nutrient, the pounds per bag, and then the cost per bag would be your first step. And then the second step would be typing in a specific formula. So again, this is why having these slides on as you come back through here. Again, this is all from Purdue's information, what we help teach our students, Dr. Cale Bigelow's class, and also Aaron Patton helped come with these, but you'll need to type in this like equal D2 divided by C2 times 43.56 in that box. And once you put that formula in, then you can drag that cell. If you click towards the bottom right corner of that cell, there's a plus sign that will appear, and you can take it and drag it down all your fertilizers, and it will automatically calculate the next row and all the formulas to help make all those calculations since you've already done it once. So again, use that plus sign, drag it down, and that will automatically calculate pounds per acre for that F column. So the next step is doing the same sort of thing, equal G2 divided by parentheses, E2 times C2 parentheses in that H2 box. And then again, you'll do the same thing. You'll drag that formula down. And then your step 4, you'll do for column I. Click the next step 4, calculating the cost per acre. You will type the F2 box, so the pounds per acre divided by the multiplication of E2, which is pounds per bag times your cost per bag. And then that formula will give you cost per acre. And again, you'll drag that formula down, column I, for all your fertilizers you've entered the information for. And then go to the next slide. And then you can just choose your product based on that. So for instance, comparing this urea to Scott's shows the difference. Cost per acre is $17 for the urea. The Scott's Turf Builder example is $86. So pretty big price difference between those two products.
And if you guys are lost, or if you're not familiar with Excel, wondering where all those letters and numbers come from, again, probably most of you used Excel, but just in case you haven't, that A1, F2, E5 things, it all goes back to the columns are arranged in letters and the rows are arranged in your numbers. So if you do get stuck along the way, in terms of what number you need to click on next, or what letters, you'll see as you could even just type it in as you go along. E2, you don't have to click on the individual cells or rows or things like that. But that's where those letters come from.
Yeah, thank you for doing that. Clearing that up. All right, next one we're going to do is calculating pesticide costs in Excel sheets, and it's going to run the same sort of method, except this time you need to make sure you know if your product, what the unit is, so whether it's going to be a dry product or a liquid product. But before you get started, you're going to run it the same sort of method. You will list all your pesticide information. You're going to calculate the cost per ounce using 16 ounces for dry products and then 28 for liquid products. So as you can see, that 5G, that G is granular, whereas the A+ fungicide is going to be a liquid, so it's in gallons. So that cost per ounce is that formula is going to change when we get to the next slide. Will change based on that specific product. And then the same thing we did with the fertilizer, you're going to calculate cost per 1,000 square feet and then cost per acre based on your information on the left. And so again, information you need is the unit size. So what's your container size or your bag size, the unit cost, and then what your rate. Again, it's based on the application rate. You need to follow the label and what your label rate is for your specific turf species and then field that you're applying this to. And again, like I said, one's going to be a granular product and one's going to be a liquid product. So you need to change that formula a little bit based on that product. So step 2, then once you've entered.
Jada, I had a question for you real quick. Sorry to put you on the spot here. Are these in 2 different columns, the unit and the actual amount for B and C?
Yes, they're in 2 different. Yes, thanks for pointing that out. So B would be the individual number, and then C would be the unit, because if you kept the letter designations in all one cell, it won't run the formula right. So you keep the numbers in one. Cost works because it can recognize the difference in cost. But when it comes to like individual numbers plus the unit designation, the unit needs to be in a separate column. So that's why it's in the C column. So when we talk about this, it may be helpful for you to put all the options of pesticides that are dry in one big section and all of the other ones that are liquid in another section. That way you can drag easily like you did with the fertilizers. But again, you're going to run the same sort of formula. That D3, your cost per unit, divided by the multiplication of your unit size by 16, converting to ounces. And then you'll do the same thing. Instead of 16, you're going to use 128 for the liquid. So then in step 3, you're just going to calculate the cost per 1,000 square feet. And so you're only going to take that $4 or 4 ounces per 1,000 in F3, multiply it by your cost per ounces, which is $1.35. And you make sure you always put that equal sign for it to do it automatically. So it would be $5.40. And you would do the same thing in typing E4 times F4 in the box to get the next one. And then you'll run the same sort of thing in H for step 4 is multiplying them, scaling up to acres. So just taking that $5.40, multiplying it by $43 or 43.56 to get your cost per acre. And you'll do the same thing for the row 4. And then you can compare those two products, and assuming they both meet your needs, and say that the Pythium Killer 5G is going to be the cheaper option for you, saving you about $10 per acre. So again, yep. So we keep going. The next slide. This is just an example that, say you had 24 different fertilizers. You could put this information in, put in all the costs per bag, and then you could just drag on the side your cost per 1,000, cost per acre, and then you could go through and compare all these different products one to another to be able to help you make that decision. So this is kind of putting it all together to show you how this could really be beneficial for you, comparing the products to purchase. So options for this, adding more information to you. We mentioned before different textbooks. The Mathematics of Turfgrass Maintenance by Dr. Christians and Michael Agnew is really helpful, and kind of where we got some of this information as well. Is really good at giving you example problems to help work with. There's also a landscape option, Mathematics for the Green Industry, for more horticulture. It's kind of the same thing. If you're doing more mulch beds and other applications, can help you as well. And then finally, there's other extension publications. If you're trying to figure out how to calibrate your specific sprayer or spreader, Purdue has put out a really detailed extension publication that's free for you to be able to help you, and it's got lots of pictures and information for you to look at. So with that, really, this is really to try to help you understand how these math and understanding how to calculate these problems are really important for helping you make proper applications from an environmental and sustainability standpoint, and then helping you reduce your overall budget to maybe do something else with that money in other areas. And again, there's lots of other options, or lots of other experts and resources and ways to help you get through these problems and help you understand how to make these applications. And so just using spreadsheets or even the traditional hand calculations can be really important. And so, updating the costs annually can help you. And especially when it comes to like these early order programs, making sure you know what to buy, when to buy, can really help save you money in the long run. So I think we've got like a minute or two.
Yeah.
But
we made it. You're a rock star, Dr. Powlen, because I felt bad. I only left you about 15 minutes there, but please, any questions you guys have, and thank you for sitting here with us the last hour. Our emails are there on the screen. We know math is challenging, whether it's in an hour or 2 hours. So we know it may have been quite a blur for you, but please reach out, utilize those resources we mentioned, and hopefully this has helped you maybe, as you start to build your program this season or think about weighing different options in your management programs.
Thank you, speakers. Doesn't look like we have any questions in the chat. We appreciate all this great information. Just a reminder, this presentation will be available in our educational conference library that is free to conference attendees and also available for purchase. And that information will be going out in the next few weeks. Thanks again for everyone that attended, and I hope everyone has a great day.